Let's now see how to generate these snippets or other summaries from single documents. Now here's an example of a snippet. This is again coming from Google. I've asked a question, was cast metal movable type invented in Korea? And Google's given me 3 little snippets with the answer, and you can see that it's bold-faced cases where words in my query occurred in the snippet. And you can see the use of ... in the snippets, telling you that it's combining pieces from different pages, different places in the page. So let's see how these kind of snippets and other kinds of summaries based on single documents are built. We can think of any summarization algorithm as having 3 stages. The first stage is content selection, extracting the sentences that we need from the document. So we have some document as input, and we're going to need to extract sentences. So we might segment our sentences off. Maybe we use sentences with periods, full sentences. Maybe we use some kind of moving window. So we've extracted some kind of little pieces, little sentences. And now from this segmented set of sentences, we want to pick the ones that are important. So I've marked those with little black dots here. We've picked some set of extracted sentences. And our next task, information ordering, is we're going to decide what order the sentences go in. So we have some now ordered set of important sentences. And finally, we might do some modifications to the sentences. Perhaps we're going to simplify them or something else. So that's sentence realization. And the result of these 4 steps is our summary. Now, the most basic summarization algorithm, and one that comes up a lot, really only uses one of these 3 steps, the content selection step. So in the simplest possible algorithm, we don't worry about what ordering the sentences come in, and we don't modify the sentences at all. We simply segment our document into sentences, or maybe they're windows. We pick the important ones, and we leave them in the same order they came in. So we're going to use what we call document order with the original sentences. So this is a very simple baseline for summarization, and one that most web-based snippet generation algorithms certainly use. The most commonly used algorithm for content selection dates back to the very earliest paper in the field from 1958. It's pretty exciting that these ideas came out so early. And the intuition is really very simple. Choose sentences that have salient or informative words. Well, what's that mean? Well, you've seen TF-IDF. That's a way of picking words that are particularly frequent and then don't contain words that occur in all documents. So that's one way we might define saliency or informativity. Turns out in summarization, we tend to use another approach, the log likelihood ratio, or sometimes called topic signature approach. And that differs from TF-IDF in 2 ways. One, we use a slightly different statistic for weighting each of the words. And second, instead of picking all the words, we'll choose only the words whose weight is above some threshold, the very salient words. Now, log likelihood ratio gives us a statistic called lambda. I'm not going to go into details, but they're in some lovely papers. And we're going to choose all words for whose the value of 2 log lambda is greater than this cutoff of 10. So that gives us a threshold for which we can pick words that are particularly salient by this statistic. So we're going to weight every word, and the weight of word I is going to be 1 if the word is especially associated with that document, meaning occurs more times in that document than in the background corpus by some threshold. Otherwise, we're going to give it a weight of 0. And again, for details about how to compute the log likelihood ratio and the intuition about the statistics, you can see this lovely Ted Dunning paper or the Lin and Hovey paper that proposed using it for summarization. Now, we want to modify this algorithm for dealing with query-focused summarization. Again, we're not interested so much in pure summarization in today's lecture, but how to use summarization techniques for question answering. So this is topic signature based, topic signature meaning pick the words that are particularly associated with a document, content selection, choosing the sentences where we've got queries. All right, and so we're going to modify the algorithm very slightly. We're going to choose words that are informative either by log likelihood ratio or words that happen to appear in the query. So we're going to weight every word in a document. We're going to give it a weight of 1 if it meets the log likelihood threshold. It passes the threshold of about 10. We're going to give it a weight of 1 also if that word happens to appear in the query or question, and otherwise we're going to give the word a weight of 0. And these weights are very simple, 1, 1, 0. You could imagine learning more complex weights, and some research has gone into coming up with very powerful ways to learn detailed weights, but 1, 1, 0 works pretty well, it turns out. And now we're just going to weigh a sentence, or perhaps it's a window if we don't have actual sentences. We're going to weigh it by the weight of the words. So we're just going to sum over all the words in our sentence of the weight of the words, and we're going to take the average. Now, the content selection algorithm we just described is unsupervised. We didn't have any labeled training set of summaries to learn weights from or things like that. So that's an alternative approach, supervised content selection. So now if we had a labeled training set where for each document we had a good summary and we had an alignment for every sentence in the summary, we knew what sentence it came from in the document, we had the matching sentences. Now we could extract all sorts of features. We could extract the position of the sentence in the document. First sentences are very likely to be good summary sentences, how long it is. We could have all the features we had before, word informativeness and things like that. We could add other kinds of features based on discourse information that we might have. And we might associate every sentence with some vector of features. And now we could just train a binary classifier. Should I put this sentence in the summary, yes or no? And it might learn weights for all these features and any other features we can come up with. Now the algorithm, this sounds good, but in practice, it turns out to be very hard to get labeled training data of this type. When people actually write abstracts for sentences, they're not always, the authors don't always use exact words and phrases, and certainly don't use entire sentences that come from the document. So finding perfectly labeled abstracts with extracts from the document is hard. It's hard to do the alignment because they don't pick entire sentences. They may be picking words or phrases or chunks. It's hard to figure out where those words came from, even when they did pick them from the document. And it turns out, surprisingly perhaps, that the performance is simply not much better than unsupervised algorithms. So in practice, unsupervised content selection, just using log likelihood ratio or other simple measures of how salient or informative a word and hence a sentence is, are the most common method for content selection. So we've seen how to generate summaries from a single document, and the baseline algorithm we picked is simply come up with a simple statistical way to find a sentence that is very informative by looking for informative words, and we talked about log likelihood ratio as an important way of finding these sentences.